Welcome to this presentation on whether two well-known buffering supplements can work better together. Sodium bicarbonate and beta-alanine each target a different part of the acid-base system. One acts outside the muscle while the other works inside. Athletes and coaches often wonder if combining them could produce greater performance gains or if it is just unnecessary complication. We will explore the science behind each supplement, what happens when you use them in tandem, and whether the potential synergy is worth the effort. Throughout this talk, we will keep the focus on evidence-based recommendations, so you can decide whether this combination belongs in your own training and competition plans. Beta-alanine enhances the body's ability to buffer acid inside muscle cells by increasing carnosine concentrations. Carnosine is an intramuscular dipeptide that binds excess hydrogen ions generated during high-intensity exercise. Sodium bicarbonate, on the other hand, raises the level of bicarbonate in the blood and helps buffer hydrogen ions once they leave the muscle. Since these two supplements act on different sides of the cell membrane, it is tempting to think that using them together might improve acid handling across the entire pathway. But a logical mechanism alone does not guarantee better performance. We need to look at the research to see if the combination actually produces meaningful results. Conceptually, stacking beta-alanine and sodium bicarbonate makes sense. Beta-alanine helps the intracellular buffering system by boosting carnosine stores, while sodium bicarbonate targets the extracellular environment by increasing blood bicarbonate. Together, they can enhance acid-base balance along the entire transport pathway from muscle to blood. However, as with any supplement, biological plausibility does not always translate into real-world results. In performance nutrition, many theoretically sound strategies have failed to deliver in practice because human physiology is complex and variable. Before adding multiple supplements to your routine, it is worth examining whether the added complexity yields a tangible benefit. Evidence for combining these two buffers is still emerging, and so far results are mixed. Some athletes report positive experiences, while others notice no additional benefit compared with taking the supplements individually. Throughout this presentation, we will examine the pros and cons of stacking beta-alanine and sodium bicarbonate, summarize the research findings, and highlight who might benefit most. By diving deeper into the science, we will help you determine whether this stack is worth your time or if it overcomplicates an otherwise straightforward supplement regimen. During high-intensity exercise, muscles produce large amounts of hydrogen ions and lactate as byproducts of anaerobic metabolism. This surge of protons lowers the pH inside muscle fibers, leading to what athletes often describe as the burning sensation. When pH drops, key processes like cross-bridge cycling and enzyme activity become less efficient, impairing force production and shortening the time to exhaustion. Buffers play a critical role by binding hydrogen ions and preventing rapid drops in pH. Understanding how and where this acid production occurs helps explain why buffering supplements can influence performance. As muscle pH falls, the ability of muscle fibers to generate power and contract efficiently declines. Intracellular buffers such as carnosine and phosphates mop up protons before they disrupt cellular processes, while extracellular buffers like bicarbonate bind hydrogen ions that exit the cell. By capturing these protons, both systems slow the fall in pH and help maintain contractile function. Without sufficient buffering capacity, acidity builds rapidly and fatigue sets in sooner. Boosting the muscle's natural buffers or adding extracellular buffers can delay fatigue, but their impact depends on the context and duration of the effort. Maintaining acid-base balance allows athletes to sustain high power for longer periods. In practical terms, buffers delay the onset of fatigue during sprints, intervals, rowing, and combat sports bouts, events where acid accumulation is a major performance limiter. By contrast, low-intensity steady-state efforts rely heavily on aerobic metabolism and generate far fewer hydrogen ions, so extra buffering is less critical. Recognizing this distinction helps athletes decide when supplementation might be beneficial and when it would likely have minimal impact. Hard intervals, sprint finishes, repeated bouts in combat sports, and CrossFit workouts all rely on rapid anaerobic energy systems and therefore produce significant amounts of hydrogen ions. These high-intensity, acid-base limited events depend on both intracellular and extracellular buffering systems to maintain performance. Conversely, endurance segments like Easy Zone 2 cardio depend more on aerobic metabolism and produce fewer protons. As a result, athletes engaging primarily in low-intensity endurance efforts are less likely to benefit from buffering supplements. Tailoring supplementation to your specific training demands ensures you are targeting the right physiological systems. Beta-alanine is a non-essential amino acid that combines with L-histidine to form carnosine, a dipeptide stored in skeletal muscle. Carnosine functions as an intramuscular buffer, binding hydrogen ions and stabilizing pH during intense work. Over time, regular beta-alanine supplementation increases muscle carnosine levels, which can improve the muscle's intrinsic ability to handle acid. Elevating carnosine requires sustained intake over weeks or months. A single dose will not meaningfully boost muscle carnosine stores. Therefore, beta-alanine is a chronic supplement rather than an acute ergogenic aid. Building up muscle carnosine requires taking roughly 4 to 6 grams of beta-alanine every day for at least 2 to 4 weeks. Splitting the total into smaller doses, about 1.5 to 2 grams 4 times per day, reduces the tingling or paresthesia that can occur with larger single doses. This supplement does not work as a one-off pre-workout ingredient. Instead, commit to consistent daily dosing to achieve meaningful increases in carnosine. Once your stores are elevated, maintaining them requires ongoing intake, though at a slightly reduced dose. Beta-alanine tends to be most effective in efforts limited by acidosis that last roughly 1 to 4 minutes. These include events like 400 to 1,000 500-meter runs, 100 to 400-meter swims, or 2 to 3-minute rowing sprints. It has little effect on efforts under 1 minute because there is not enough time for significant acid buildup, and it does not appreciably enhance repeated sprint protocols where rest periods allow for pH recovery. Choosing beta-alanine makes sense when your training or competition includes sustained high-intensity bursts within that 1 to 4 minute range. The most commonly reported side effect of beta-alanine is paresthesia, a harmless tingling sensation often felt in the face, neck, or hands. This sensation is dose-dependent and usually appears when individual doses exceed around 800 milligrams. Splitting the daily intake into multiple smaller doses or using sustained-release formulations can reduce the intensity of tingling. Some individuals find the sensation distracting while others barely notice it. It is important to remember that the tingling itself is not harmful, and consistent dosing over time tends to diminish the effect as the body adapts. Sodium bicarbonate ingestion raises the concentration of bicarbonate in the blood, creating a slightly more alkaline environment. This extracellular buffer binds hydrogen ions that exit muscle cells, facilitating their removal and helping maintain pH. Because bicarbonate works outside the muscle, it complements intracellular systems like carnosine and phosphate buffers. Unlike beta-alanine, sodium bicarbonate acts acutely. You take it a few hours before your event or training session to boost blood bicarbonate temporarily. Its effect on pH is transient, peaking and then returning to baseline within several hours. Sodium bicarbonate is used on performance day rather than as a chronic supplement. After ingestion, blood bicarbonate and pH rise and reach a peak anywhere from 60 to 180 minutes later, depending on the dose and individual variation. The supplement is most effective for efforts lasting approximately 30 seconds to 10 to 12 minutes, the window where acid accumulation limits performance. Taking bicarbonate too early can cause the effect to wane before your event, while taking it too late may not allow enough time for bicarbonate levels to rise. Timing your dose properly is critical. Standard single-dose protocols involve consuming about 0.2 to 0.3 grams of sodium bicarbonate per kilogram of body mass, 1 to 3 hours before exercise. Doses above roughly 0.3 grams per kilogram rarely provide extra benefit and tend to increase gastrointestinal distress. Multi-day protocols use around 0.4 to 0.5 grams per kilogram per day, split across meals for several days leading up to an event. This approach may build up extracellular buffering capacity more gradually and improve tolerability. Always test your chosen protocol in training to discover what works best for you. Gastrointestinal distress is a primary limitation when using sodium bicarbonate. Common symptoms include bloating, nausea, diarrhea, and stomach cramps. These issues often intensify with higher doses and in individuals who are sensitive to sodium or have pre-existing digestive problems. Strategies to improve tolerance include splitting the total dose into smaller portions, taking it with a carbohydrate-rich meal, or using enteric-coated capsules that delay dissolution until the intestine. No matter which method you choose, it is essential to test your personal tolerance during training, well ahead of race day. When you combine beta-alanine and sodium bicarbonate, you are targeting both sides of the acid removal system. Beta-alanine increases intramuscular carnosine, which binds hydrogen ions inside the muscle. Sodium bicarbonate boosts blood bicarbonate, binding hydrogen ions once they leave the muscle. In theory, enhancing buffering along the entire pathway should improve hydrogen ion clearance more effectively than using either supplement alone. This approach could provide greater fatigue resistance during high-intensity events. However, whether the theoretical synergy translates into real performance gains depends on many factors, including the type of event and the individual athlete's response. Beta-alanine and sodium bicarbonate differ not only in where they act, but also in how they are used. Beta-alanine is a chronic supplement. It requires weeks of consistent intake to elevate carnosine stores within the muscle. Sodium bicarbonate is an acute supplement. Taken hours before an event, it temporarily raises blood pH. Combining them therefore provides long-term intracellular support with short-term extracellular alkalosis. This dual approach could theoretically create a more robust buffering system that spans the time and space of hydrogen ion transport from muscle to blood. Even though the mechanisms of beta-alanine and sodium bicarbonate complement each other, performance gains are not guaranteed. The effectiveness of the combination depends on the sport, the intensity and duration of the event, the athlete's training status, and individual variability in supplement response. Additive benefits may occur only in specific contexts, and what works for one athlete may not work for another. Recognizing this variability is important before making sweeping conclusions about co-supplementation. The research on combining beta-alanine and sodium bicarbonate is still limited and shows mixed outcomes. Some studies report greater performance gains from co-supplementation than from either supplement alone. These improvements range from modest to moderate, depending on the protocol and the performance test used. Other studies find limited or no extra benefit, often due to small sample sizes and variations in dosing, timing, and athlete characteristics. Because of the heterogeneity in study designs, it is difficult to draw definitive conclusions at this stage. More robust and standardized trials are needed to clarify who, if anyone, consistently benefits from the stack. A recent meta-analysis published in 2024 looked at the combined effects of beta-alanine and sodium bicarbonate compared with each supplement alone. Interestingly, the researchers found no significant ergogenic effect when analyzing beta-alanine or sodium bicarbonate individually. However, the combination produced a small but statistically significant improvement in performance. The effect size was modest, meaning the actual gains were moderate rather than dramatic. These results hint at true synergy, but also highlight the need for cautious interpretation due to the limited number of studies and their varied quality. Based on current evidence, co-supplementation may be worthwhile for events limited by acid-base fatigue lasting between 1 and 4 minutes, or for repeated bursts separated by short rest periods. Some studies report performance improvements ranging from 2% to 16%, but these estimates come from small groups and specific protocols. Before recommending the stack broadly, researchers need more trials with larger sample sizes, standardized dosing, and well-defined performance tests. In the meantime, athletes can experiment with the combination during training if their events fit the acid-base profile. To build muscle carnosine, take 4 to 6 grams of beta-alanine each day, split into approximately 4 doses of around 1.5 to 1.6 grams to minimize tingling. Continue this regimen for at least 4 weeks to see meaningful increases in intramuscular carnosine levels and maintain daily intake thereafter to preserve those stores. Combining supplementation with a balanced diet and adequate protein intake supports carnosine synthesis. Remember that beta-alanine is not an acute ergogenic aid. It works by increasing your baseline buffering capacity over time. For sodium bicarbonate, the standard acute dose is roughly 0.2 to 0.3 grams per kilogram of body mass, taken between 60 and 180 minutes before exercise. Because the optimal timing varies among individuals, test different intervals in training to determine when your blood bicarbonate peaks without causing stomach upset. Some athletes use a multi-day loading protocol of around 0.4 to 0.5 grams per kilogram per day, divided across meals to build extracellular buffering gradually. Enteric-coated capsules and co-ingestion with carbohydrates can also improve tolerability. Let's put those dosing recommendations into perspective with specific examples. A person weighing 60 kilograms would take between 4 and 6 grams of beta-alanine per day, split into doses of about 1 to 1.6 grams each. For sodium bicarbonate at a dose of 0.3 grams per kilogram, that same person would ingest approximately 18 grams a few hours before exercise. Someone weighing 80 kilograms would take roughly 4.8 to 6.4 grams of beta-alanine daily and around 24 grams of sodium bicarbonate pre-event. At 100 kilograms, beta-alanine intake would be around 6 grams per day, and a 0.3 gram per kilogram dose of sodium bicarbonate equates to 30 grams. Regardless of body mass, always use a scale to measure out your doses precisely and test them during training. Let's put those dosing recommendations into perspective with specific examples. A person weighing 60 kilograms would take between 4 and 6 grams of beta-alanine per day, split into doses of about 1 to 1.6 grams each, for sodium bicarbonate at a dose of 0.3 grams per kilogram. That same person would ingest approximately 18 grams a few hours before exercise. Someone weighing 80 kilograms would take roughly 4.8 to 6.4 grams of beta-alanine daily and around 24 grams of sodium bicarbonate pre-event. At 100 kilograms, beta-alanine intake would be around 6 grams per day, and a 0.3 gram per kilogram dose of sodium bicarbonate equates to 30 grams. Regardless of body mass, always use a scale to measure out your doses precisely and test them during training. Side effects are a key consideration with any supplement regimen. Beta-alanine tingling is benign but can be distracting. Dividing the total daily dose into smaller portions or choosing slow-release formulations reduces sensation. For sodium bicarbonate, gastrointestinal distress is the major concern. Symptoms such as bloating, nausea, diarrhea, and stomach cramps tend to worsen with higher doses. To improve compliance, lower the dose, split it into multiple smaller servings, take it with a carbohydrate-rich meal, or use enteric-coated capsules. Consistent adherence is essential for both buffers to confer any benefit. If you cannot tolerate one or both supplements, the potential advantages disappear. To improve beta-alanine tolerance, split the total daily dose into 3 or 4 smaller servings and take them with meals. This approach minimizes tingling and fits the supplement into your regular eating schedule. For sodium bicarbonate, determine your individual time to peak by adjusting the time between ingestion and exercise. Start by taking the supplement 2 hours before your session and then adjust earlier or later based on how you feel and perform. Use gastro-resistant capsules to delay release, co-ingest with carbohydrates to slow gastric emptying, and consider multi-day loading to build up buffering capacity gradually. These strategies can help you reap the benefits of both buffers without undue discomfort. The combination of beta-alanine and sodium bicarbonate is best suited for competitive athletes engaged in sports that require repeated high-intensity bursts, such as rowing, swimming, middle distance running between 400 and 1500 meters, cycling races with surges, combat sports, and functional fitness competitions like CrossFit or High Rocks. Casual gym goers and athletes whose events rely on pure maximal strength or long low-intensity endurance are unlikely to see meaningful benefits. Individuals who are sensitive to sodium, prone to gastrointestinal distress, or simply uncomfortable with multiple supplements should proceed with caution or opt out altogether. In summary, beta-alanine provides chronic intracellular buffering by increasing muscle carnosine, while sodium bicarbonate offers acute extracellular buffering by raising blood bicarbonate. The stack is mechanistically promising and a few studies suggest a modest additive effect. However, results are not universally positive and the performance gains, while statistically significant, are generally small. Thank you to combining these supplements if your event is genuinely limited by acid buildup and you can tolerate both products. Always test the combination during training before using it in competition, and weigh the potential benefits against the added complexity and cost. Both supplements require attention to safety. Sodium bicarbonate introduces a significant sodium load, so people with hypertension, kidney disease, or heart disease should consult a healthcare professional before using it. Never trial sodium bicarbonate for the first time on race day. Test your tolerance well in advance and monitor your blood pressure and overall well-being. Beta-alanine tingling is typically harmless but can distract some users, so adjust your dose or timing if necessary. As with any supplement, listen to your body and seek advice from a qualified practitioner if you have underlying health conditions or concerns.